There we go. Zinc and hydrochloric acid was the last reaction we saw. It was a what type of reaction? A single replacement reaction. Single replacement, remember, there's one element and a compound. After the reaction occurs, you get a different single element and a different compound. Think of it like this. You know, you drag your best friend on a date with you, like she feel bad, oh, come on, you can join us for movies. So your friend walks in with you and your date, you walk out of the movie by yourself, and your friend is with your date. Not cool. Okay? But that's kind of, it's a single replacement. Okay? Then finally, a double replacement. Double replacement reactions are two couples, so two compounds. Got this couple here and this couple here. And then at the end, they switch partners. So she is now with this guy and she is with that guy. So A and B start out and A and B come out at the end. Okay? It's like a really bad double date gone wrong. Something like that too. Yeah. It's just weird. Okay. We good? So notice that cation, anion, cation, anion. The anion switch places. So we still have a cation and anion, a cation and anion. You can't have two cations or two anions together. It doesn't work that way. You have to have a cation with the anion. My husband thought it was a good thing. I was talking about this and showing the videos, and he goes, well, that's smart that you made the girl the cation. And I'm like, well, of course, we're positive. He goes, no, because you're a bunch of catty people. But he said something else, and I'm like, oh, well, one, that's actually a really good way of looking at it. The two, no. So I was torn with my response to him. I was like, yeah, but no, yeah, no. Okay? So, in a double replacement reaction, compound goes in, different compound comes out, different compound comes out. Look for your compounds. Compound plus compound, making two new compounds is a double replacement reaction. Okay? Yes, sir?
What is the S?
Means it's a solid. Those tell us the states of matter. So that's aqueous, which means it's been dissolved in water. Aqueous dissolved in water, the solid comes out, and the rest of it's dissolved in water.
How do we know it's been turned into a solid?
You will learn that on Monday. So we'll be doing double replacement reactions probably maybe Friday afternoon into Monday. And you'll have another lab on Tuesday. You have a lab tomorrow, a lab on Tuesday. And I don't know if we'll get done before spring break or not. I don't know. But I do need to know how many of you guys will be working different things. You're supposed to be in class during the time you're supposed to be in class. So make sure you're talking. I'll let you go at some point in time, but you're supposed to be here. Okay? Well, let's see what we have planned first. Okay. Now, double replacement reactions, like Sean said, notice you have an aqueous solution, and it makes some type of solid. These are our precipitation reactions. Remember when you took your copper 2 nitrate, the first step in your last lab? You took copper 2 nitrate and you put some sodium hydroxide in it. It was a clear, colorless liquid and a clear blue liquid. You put them together and it made a solid, the copper 2 hydroxide. That was a double replacement reaction. Precipitates are typically known from double replacement reactions. They're not terribly fun, exciting, scary, blow-up-y. They don't do that. They usually make it precipitate, and that's about it. Or a gas. The carbon dioxide. That's typically what comes up. Okay? Does that make sense? So we're not going to look at those because it's like, whatever. Okay, learning check. I know the arrows are out of place, I apologize for that, but what's this first one? Single or double? Single one, double two. Tell me. Single one, double two. Raise your finger. Yeah, give me a finger. There you go. Single or double?
Single.
I want a finger from everybody. It is a single. Single element, compound. Makes a compound and a new single element. You've got to look for the single element. What about the second one, one or two?
Two.
Okay, thank you for screaming out loud, I appreciate that. Two. And one or two for the third one. It is one. Single element, compound, new single element, compound. You have to be able to recognize these. And the final thing we're going to talk about is combustion reactions. Combustion reactions are very easy to identify. They're easy to identify because there's always a hydrocarbon. A hydrocarbon is a hydrogen and carbon together. That's called a hydrocarbon. Okay? And it always reacts with oxygen. And it always makes carbon dioxide. And it always makes water, no matter what. Those things are always made. Whether it be this, whether you have C2H2 plus O2 yields CO2 plus H2O. I could have C3H6 plus O2 yields CO2 plus H2O. I could have C5H10 plus O2 yields CO2 plus H. They're always the same. It's always a hydrocarbon reacting with oxygen. Always. Okay? And it always makes carbon dioxide and water, no matter what. Even if it's like this, C6H12O6 plus oxygen yields carbon dioxide and water. That's sugar. Burning the sugar. This is photosynthesis right here. That is a combustion reaction. It gives energy. Okay? It gives off energy and heat, things like that. Your fossil fuels in your car. That's why it's called a combustion engine. It undergoes combustion and that's where I'm trying to think of it enough. You know, it burns the fuel, makes the pistons go up and down by the energy. But your cars are not a complete combustion reaction. They're called incomplete because they don't make carbon dioxide. They make carbon monoxide. And the carbon monoxide is obviously extremely dangerous. That's why you don't start your car in your garage and don't open the garage door and things like that. That's a terrible thing because it's very toxic. Now let me show you a combustion reaction back here. Son of a gas! Oh my God, you're so right. No wonder it's not doing it. Oh, drat the luck. But I think it's still, I wonder if it's still recording. Oh no. Oh well. Thank you. I forgot all about doing that. I got so used to just doing it. Dang it. Thank you. Scott, wait until that 10 minutes. Well, maybe it says all talk. I don't know. Okay, so I'm going to take some potassium chlorate. Potassium chlorate, when it decomposes, will make potassium chloride and oxygen. We need oxygen, obviously, for our combustion reaction. Okay, so in order to drive the oxygen, get the oxygen out of it, I need to heat it. It needs to melt because the oxygen has to come out of the compound. And then I'm going to sacrifice a little gummy bear for science sake. Sake of science. Let's heat this up a little bit. It's an ionic compound, so it takes a little while to melt. I wish I had like elevator music for times like this, just very elevator music.
I can sing if you want.
Okay, go ahead.
No.
Row. It's bubbling. Let's see, I'll bring this back. You do me a favor, we push the video back a little bit.
She's talking to me. No, I thought she was like, oh, dude. Put it where? Backwards?
This way. There you go. Perfect, actually. Thank you. And in a few minutes, if I could get someone to turn the lights off, I'd be much appreciative. Okay, so it's almost a liquid now, so there's all kinds of oxygen coming off this thing right now. It's like, woo, oxygen. I love oxygen. So, now it's all liquefied. Poor little, here comes the little sacrificial. Ready? Want to turn off the light? All the way off. Screaming. Like a volcano, we're freezing the volcano. That's carbon. There's a lot of carbon. There's a lot of water vapor as well. Okay. So can you turn the lights back on, please? You can see the. I don't think it even existed anymore. Okay. So that's a combustion reaction. It's still there fizzing around a little bit, but you saw the energy that's given off. Combustion reactions give off lots of energy. Okay. So when you get that hydrocarbon with the oxygen, you got a lot of smoke here as well. That's carbon that's in water vapor and stuff like that. Some carbon dioxide's in it too. Blah. Okay? So if someone wants to crack a window, you're welcome to. I know it's kind of stinky winky in here. Okay. So combustion reactions are fun.